Motion, Part 3. Speed with direction. In the previous video, we learnt about uniform and non-uniform motion and about speed. In this video, we will learn about speed with direction or velocity and the rate of change of velocity or acceleration. Let's start by considering an object moving at a certain speed, let's say 10 meters per second. Now, along with the speed, if we specify the direction of motion also, then the whole quantity is known as velocity. Velocity is the rate of change of displacement of an object. Or simply, velocity is the speed with direction. So, if a car is going at 60 km per hour, this is its speed. But when we say the car's speed is 60 km per hour towards the east, then it becomes velocity. Speed equals distance covered by time taken. Its SI unit is meter per second. Velocity's SI unit is the same as that of speed and is meter per second. Now, velocity also can be uniform and non-uniform. The velocity of an object can be changed by changing either its speed or the direction of motion or both. As we are considering only the motion in a straight line, if an object moving with a velocity which is varying with time, we can express the magnitude of its rate of motion in terms of average velocity, just like the average speed which we described in the previous video. If the velocity of an object is changing at an uniform rate, we can calculate the average velocity by simply taking the arithmetic mean of the initial and the final velocity for the given time interval. Average velocity is equal to initial velocity plus final velocity, the whole divided by 2. Mathematically, V average is equal to U plus V whole divided by 2. Where V average is the average velocity, U is the initial velocity and V is the final velocity of the object. Have you seen a speedometer in a car? What does it measure? Is it speed or velocity? Earlier, we learned about the rate of motion, which is the rate of change of position of an object in the given time interval. Now, let's study the rate of change of velocity. Suppose a car is in uniform motion moving on a straight road. Its velocity doesn't vary with time and hence remains constant. The change in velocity with respect to time is 0. Now, consider if the motion of the car is non-uniform and so its velocity varies with time. Thus, the change in the velocity in the given time interval is not 0. To represent this rate of change of velocity, here comes another physical quantity which is known as acceleration. So, the acceleration of an object is a measure of the change in velocity per unit time. That is, acceleration is equal to change in velocity divided by the time taken. SI unit of acceleration is meter per second square. If the velocity of an object changes from an initial value u to the final value v in time t, the acceleration a is equal to v minus u whole divided by t. This kind of motion is known as accelerated motion. Acceleration is taken to be positive if it is in the direction of velocity, and negative when it is opposite to the direction of velocity. This negative acceleration is called retardation. Here also, acceleration can either be uniform or non-uniform. Suppose if a car starts from rest, it starts moving on the straight road with a constant acceleration of 5 meters per second square. The velocity of the car at t is equal to 1 second is 5 meters per second. At t is equal to 2 seconds, velocity is 10 meters per second, and so on. As its velocity is increased by an equal amount in equal time interval, the acceleration is said to be uniform. On the other hand, if the same car increases its velocity by unequal amounts in equal intervals of time, then the car is said to be moving with non-uniform acceleration. Let's take another example. Take a ball to the roof of your house and release it. You will observe that the ball is in uniform accelerated motion. This is because the acceleration due to gravity is constant. You will learn about gravity in chapter 10. Now let's look at some examples. A. Acceleration is in the direction of motion. Here, when the driver pushes the accelerator pedal, the car starts from rest and the speed keeps on increasing. Here, the acceleration is positive. B. Acceleration is against the direction of motion. Let's observe a moving car. Driver applies the brake and the car slows down. Although the car's direction of motion is towards right, but the acceleration is applied in the opposite direction. Here, we can say that the acceleration is negative. C. Acceleration is uniform. When the driver pushes the accelerator pedal and keeps it at a certain position, the speed increases at a uniform rate. D. Acceleration is non-uniform. Now, the driver pushes and releases the accelerator pedal repetitively for different time intervals, which gives the car jerks along with the increase in speed. So, in this video, we learned about the speed with direction or velocity and the rate of change of velocity or acceleration.